Hello my algebra friends, welcome back to Mr. Farina's Algebra 1 class. Today we will be discussing how to factor out the greatest common factor. Now this is kind of the first part of many parts of our factoring unit. Now before we begin factoring out the GCF, we're kind of hit a review of multiplying a monomial times a polynomial. And the reason we're going to start with a monomial times a polynomial is because with the greatest common factor, that's the type of ending we will end with. Let's take a look at the first example here. If I take the term 3x and multiply it by the trinomial 4x squared minus 6x plus 5, all I'm really doing is, completing the distributive property and getting 3x times 4x squared to be 12x to the third. 3x times negative 6x is minus 18x squared. And 3x times 5 is 15x. Now, our goal today is to factor. And if you look at the definition below of factoring, okay, we are going to be expressing a polynomial as the product of monomials and polynomials. Meaning, we are going to start with this polynomial, 12x to the third minus 18x squared plus 15x, and work backwards to get this and write it in terms of a monomial times a polynomial. Okay, I like to call this reverse multiplication, such as you're going to be giving, say, the polynomial 8y squared plus 10y. And your goal is going to be to factor this, and after you factor it, you will get a product of the monomial 2y times the binomial 4y plus 5. Now, before we truly jump into this, we're going to go ahead and talk about some elementary math concepts such as common factor and the greatest common factor. Now, if you can remember what a common factor is, this is a whole number that is a factor of each number in a set of numbers. So, for instance, say we take the number 12 and the number 16. Okay, if we go and list all the pairs of factors, meaning the factors are the numbers we multiply to get the products. So if I take all the pairs of numbers that multiply to give me 12, such as 1 times 12, 2 times 6, 3 times 4, and that's it, right? Yep. Now, the factors of 12 then would be the number 1, the number 2, the number 3, the number 4, 6, and 12. Now, if we take the number 16 and we write all the numbers that multiply to give us 16, such as 1 times 16, you got 2 times 8 and 4 times 4. So basically the factors of 16 would be 1, 2, 4, and 16. Oh, 4, 8, and then 16. Now, the common factors are basically going to be the numbers that is in both sets of factors. So, when we go to find the common factors, I should say, we would say, okay, factor in each of them was a 1, so that's a common factor. It was 2 in each set of factors, yes, so 2 is a common factor. Was 3 in both sets? No, it is not a common factor. But 4 was in both sets, therefore it's a common factor. Alright, were 6 and 12? Nope. So the only common factors between the number 12 and 16 would be 1, 2, and 4. Now, even more important for factoring out the greatest common factor is being able to find the greatest common factor between two terms. Now, before we used to find common factors between two numbers, but now when we say two terms, we can have coefficients which are numbers and variable expressions. So if we wanted to find the greatest common factor, what we're basically looking for is the greatest number or variable expression that is a factor, alright, of two or more numbers. Now, we're going to start easy here and say if I gave you the term 12x to the third y and the term, say, 16 x to the second y to the fourth. Okay, now what we're going to do is we're basically going to break this up. Now our goal is to find the greatest common factor. Now the coefficients 12 and 16, if you look up above, we already found the common factors, right, of 12 and 16. Well, the greatest common factor between 12 and 16, alright, is going to be the largest common factor. Well, in the list of common factors you have 1, 2, and 4. Which one is the largest? 4. So this greatest common factor between 12x to the third y and 16x squared y to the fourth is actually going to start out with 4. Now, if that's the greatest common factor, what I want to do is break 12 up into, say, 4 times 3. Then I'm going to break these variable expressions up. So x times x times x, because I have 3 x's, x to the third can be written out like that, times y. Then I'm going to break 16 up. We said the greatest common factor is 4. So how can we keep 16 written as a product using 4? Well, 4 times 4. Then x times x times y times y times y. The reason I have 4 y's and 2 x's is because the exponent on x is 2, the exponent on y is 4. Well, it seems like the coefficients, it's easy to find the greatest common factor between them. Okay, 12 and 16, no problem. But how do we look at the variable expressions? Well, if I look at it, starting with the x's, the greatest common factors for the variable x's, how many do they have in common? Well, they have one pair in common here and another pair in common here. So how many pairs do they have in common? Well, they have 2 pairs. So what we're going to say is the greatest common factor for between x to the third and x to the second will actually be the 2 pairs to give us x to the second. Now, for the y's, well, how many pairs do they have in common? Well, if I look at this, I can only wrap around, one pair. So they actually only have 1 y in common. Now, what you actually end up noticing is for variable expressions, okay, the greatest common factor will equal the lowest or smallest exponent. So if I look at the exponents on x to the third and x to the squared, I know my greatest common factors would be x squared. If I look at y and y to the fourth, I know y has the smallest exponent, therefore that's the greatest common factor. Now, our goal today is to actually put this all together and learn how to factor out the greatest common factor. Now, the 2 steps here. One, our first step is to find what the GCF is. So in all the terms, we need to find what the GCF is. Then, once we find the GCF, we're going to divide each term by the GCF and write our final answer as a product of the greatest common factor and the leftover polynomial quotient. So we have a few examples down below. So let's take a look at this. Now, when I look at the coefficients of 2 and 6, alright, I want to think, what is the largest number that can go into 2 and 6 evenly? Okay, or what can they both be divided by? What's the largest number they can be divided by? Alright, to get an answer that's a whole number. Well, that number is 2. Now, if I look at my variable expressions here, x squared and x, okay, what is the smallest exponent here? Well, that smallest exponent is 1, so our greatest common factor here is just going to be 2x. Now, we're not done, because we want to factor out the greatest common factor. So, once I know what my greatest common factor is, I'm going to divide each of these terms by the greatest common factor. Now, once I divide, I know I'm going to pull my greatest common factor out, and I'm going to write it as a product of the greatest common factor and the leftover polynomial quotient I get. So once I'm done dividing here, that's what would go inside these parentheses. So let's look at it. If I go to simplify this expression, 2 divided by 2 is 1. Do you have to put the 1? No. X to the second divided by x. If I have 2 x's on top, 1 on bottom, where do I have more? Up top. And by how many? 1. Okay. Minus, what's 6 divided by 2? 3. And if you notice, both x's cancel. And my final factored form is going to be the polynomial 2x times the binomial 1x minus 3. Hopefully that wasn't too bad. Alright, let's step it up a notch. Okay, let's look at this one. First, let's find the greatest common factor. Well, what's the greatest common factor between 15 and negative 3? Well, I know the only factors for 3 are 1 and 3. Well, that makes it easy here because the greatest common factor between the coefficients is going to be 3. Now again, when we look at our variable expressions, our GCF is always going to be the smallest exponent. Okay, because once I'm done dividing, I do not want remainders or fractions left over. Now, if I have x here and x to the second here, alright, what is my GCF going to be? Well, the smallest exponent is 1, so it's just going to be x. And if I look at y to the third and y to the second, what's going to be my GCF? The smallest exponent is y squared, therefore it's going to be y squared. Now, in order to factor out the greatest common factor, I'm going to pull that GCF out. Now, I still have to find out what goes inside these parentheses. Well, how do I do that? I'm going to divide each of these terms by my GCF. Okay, and whatever I get left over is going to be what's going inside these parentheses. So, 15 divided by 3 is 5. I have 1x on top, 1x on bottom. They cancel out. If I have 3 y's on top, 2 y's on bottom, I can cancel out 2. Alright, if I take 2 off the top, how many do I have left? 1. Or, as Miss Godfrey would say, how many y's do I have on top? 3. How many do I have on bottom? 2. Okay, where do I have more and by how many? Well, I have 3 y's on top, 2 y's on bottom. So I have more y's on top and by how many? 1. Minus 3 divided by 3 is going to give you 1. Do I have to write that? No, but it just helps out for some of us. If I have 2 x's on top, 1 x on bottom, how many can I cancel? I can cancel 1. How many do I have left? 1. And if I have 2 y's on top, 2 y's on bottom, all the y's cancel out. And this is our final answer. Okay, so as you can see, we're moving in baby steps here. Hopefully that problem makes sense and you are ready for this final example. So let's take a look at it. GCF. Now I actually have more than 3 terms to work with. Okay, 16, 36, 24. Now generally what I like to do is think about all the factors of the smallest coefficient. Okay, 16. Alright, I know the factors of 16 are 1, 2, 4, 8, and 16. So what I do is I start from left to right and I ask myself, is 36 divisible by 16? No, that's not going to work. Is 36 divisible by 8? No. Then I move on to 4. Is 36 divisible by 4? Yes, but I have to check. Is 24 divisible by 4? That's a yes. So 16, 36, and 24 are all divisible by 4, so that's the greatest common factor between the coefficients. Now, if I look at my x's, okay, I have 2 x's here, I have 1 x here. Do I have any x's here? No. If one of the terms does not have a variable, okay, that variable expression does not have a common factor. So you cannot factor out any x's in this problem. Now, here I have 3 y's, 4 y's, and 2 y's. What is my smallest exponent? 2. So I'm going to pull out the y squared. And finally, I have z, z to the third, z to the third. What's my smallest z? This one right here. So I can pull out 1z. So my greatest common factor here is 4y squared z, okay, times. Well, how do I figure out what goes inside the parentheses? You guessed it. I'm going to go and divide every single term by that GCF. Divide by 4y squared z. Divide by 4y squared z. Divide by 4y squared z. So, 16 divided by 4, 4. Okay, I don't have anything to cancel out the x's, so I have to keep them. I have 3 y's on top, 2 on bottom. So I have more y's on top by how many? 1. And these 2 z's cancel out. Plus 36 divided by 4 is 9. Excuse me. I can't cancel out that x, so I have x. I have 4 y's on top, 2 on bottom. So I have more on top by 2. And if I have 3 z's on top, 1 on bottom, I have more z's on top by 2. Minus 24 divided by 4 is 6. I have 3 z's on top. Let's actually start with the y's to keep it in alphabetical order. Those y's eliminate. Then I have 3 z's on top, 1 z on bottom, to give me z to the second. Notice, once I am done dividing in all of these, okay, once I factor, I do not end up with any fractions. If I end up with a fraction, I know I made a mistake somewhere. Okay, remember, you always pull out the smallest variable expression or exponent for the variable. Okay, that is critical to know and understand. Hopefully this helped you enough to go ahead and attempt the practice problems in order to be prepared for class tomorrow. Thank you for your time.